Okay, this is the second part in Chapter 1, Lesson 5, and we left off doing some vocab. We stopped at coordinates. We do have a little more vocab to do, and then we'll talk about why we're talking about graphing right now in this lesson. So, um, two more words. I'm going to leave them both up there right now. Linear. Linear is a straight line. So it's a graph, and in that graph, the line is straight. No curves, no bends, nothing that looks anything other than a straight line. Okay? And the last vocab word, which is probably the most important one for our chapter, is proportional graph. So in 1.4, we talked about how to identify a proportional relationship by building a table and finding all of the unit rates or simplifying all the ratios to see if they're all equal. In 1.5, we're going to graph those relationships and we're going to see if the graph is proportional. And a lot of students really like this method. So a proportional graph has two qualities. It's a graph that's linear, so it means it's a straight line, and it also has to pass through the origin. Remember what we reviewed from the last video? The origin was that point, 0, 0, where it was kind of the center of the coordinate plane where the x and the y-axis intersect. So just in case you want to write that down, 0, 0 is what we call the origin. Okay? All right, so on the next page in your notes, you have all of this from the last video. We just want to add two little notes about what a proportional graph and what a non-proportional graph would look like. So a proportional graph, remember the two qualities of a proportional graph. It has to be linear and it has to pass through the origin. So mine's going to pass through the origin, that's 0, 0, and it's going to be a straight line. Okay, so the example I have right here is my proportional graph. I could draw a couple different examples. It could go, up a little steeper like that, or it could be a little bit less steep, something like this. So any of those three graphs would be proportional because they are linear and they pass through the origin. Now, the non-proportional examples, we can draw several of those as well. We'll change colors for that. Let's make our non-proportional graphs orange. And our non-proportional graphs, they have to be either nonlinear or not passing through the origin. So here's an example that we can talk about. That's not proportional. Even though it's linear, it doesn't pass through 0, 0. Here's another example of a non-proportional graph. Okay. It does pass through the origin, but it is not linear, so it's non-proportional. Okay, so you can draw your own couple examples there, but basically a non-proportional graph doesn't meet the criteria required to be a proportional graph, which is linear and passing through the origin. All right, so let's do our examples. This is what we've been waiting for. Our first example says James earns $15 per hour mowing lawns. Is the money he earns proportional to the hours he works? So it's setting us up with a table here, and this time we've added some things to the table. We've added x and we've added y, and that's to help us graph. The top number is going to be our x, our walk coordinate, and the bottom number is going to be our y, or our jump coordinate. So James, we can do a couple different things with this table. We can start off at 0 if we'd like to see how much money he would make if he works 0 hours, and that is $0. So that will help us to see if our line, if our graph is going to pass through the origin. You can do that, you don't have to do that, but in this case, we'll put a 0 there to test it. If he works for 1 hour, he's going to get paid $15. If he works for 2 hours, he'll get paid $30. If he works for 3 hours, he'll get paid $45. And if he works for 4 hours, he'll get paid $60. So what we want to do is we want to check to see if this relationship produces a proportional graph. So the first thing we need to know is we could go ahead and do all the unit rates for this table, and we could find out that it's proportional that way. But this is a different method we're trying to test out here, the graphing method. So our x numbers, they're going to be plotted across the x-axis, and these are hours. And what I'm going to do is there's a lot of lines across my x coordinate, so I'm going to maybe skip every 3 and make that every third one bold there. And that'll help me graphing and make my graph a little bit easier to read. So this is going to be 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, and 6 hours. Now I need to make this y coordinate or y-axis my money, and I'm going to count by 2's here, every other one, and I'm going to make each of those worth $10. So you can play around with your number lines a little bit to help you show a good graph. The reason our coordinate planes have so many grid lines is because we can get as accurate as we want, or we could do kind of what I'm doing here and skip count a little bit. Whatever you're doing, make sure you always keep the distance between all your tick marks the same and the value between them the same. Like I can't just jump up by 1, 2, 3 and then jump up to 7. All right, so let's plot these points. Remember, the first number is the x number, the second number is the y number, so that's 0, 0. I'm going to walk 0 and jump 0, so I'm plotting my point at the origin. Next is 1, 15, so I walk over to 1 hour and I find where $15 would be on the y coordinate and place a point there. 2 hours, $30. 3 hours, $45. 4 hours, $60. And then I want to draw a line through my graph. I'll make my line green. Maybe. All right, maybe it'll just come out black. Oh, there we go, green. So there's my line. And you'll notice about with my line that I've got 2 things going on. My line, my graph passes through the origin, and it is definitely linear. So I will say this is a proportional graph. Okay? Passes through the origin and it's linear. So every time we do one of these problems, it will ask for an explanation. So I'm going to type mine, it'll be a little faster. My explanation is the money is proportional to the hours he works because the graph is linear and passes through the origin. Notice I've got that important information from the question. Is the money proportional to the hours? So I'm answering the question and I'm telling about the graph. The graph is linear and it passes through the origin. Okay, let's see one more. This one's a little faster because the table's already built for us. It says Maddie recorded her heart rate after every 2 minutes of exercising. Is her heart rate proportional to the number of minutes she exercised? All right, so we can go ahead and we can do our table again. I'm going to skip 3 this time. And that'll be 2, 4, 6, 8, and 10 minutes down here on the x coordinate. There we go. And here I'm just going to do 50s. I'll do 50 here, 100, 150. Probably could do a lot more of an accurate graph here, but I'm trying to make the video shorter. I know it's getting a little bit long. And those are going to be the beats, heartbeats. So first, 0, 65, and that's somewhere around here. 2, 95. 4, 110. 6, 120. And 8, 120. Let's take a look at that graph. So here's pretty much what our graph looks like. If you take a look at that graph, you can see that, first of all, it's not passing through the origin. Second of all, it's not a linear graph. So we are not meeting any of the criteria here for this to be a proportional relationship. So if we want to write our explanation, again, I'm going to type mine to make it quick. I would say her heart rate is not proportional to the number of minutes because the graph is not linear and does not pass through the origin. So neither one of those criteria was met in that graph. Okay, the toughest thing about this lesson is actually numbering your number lines, in my opinion. So just keep practicing on how you want to number your graphs, but the graphing itself is very, very easy. Okay, ask any questions in class tomorrow, and don't forget to make flashcards for your vocab.